known as valence shell electron pair repulsion theory. Okay, is used to describe the molecular geometry of a molecular compound. Okay, all right. So we have two types of geometries. Okay, one is electron geometry. Okay, and then the second one is molecular geometry. So don't forget that we have, please do not forget, at least you have to remember, you have to memorize the basic electron geometry. So in total, we have 5 electron geometry. Okay, please take note that electron geometry is based on electron group surrounding the central atom. Okay, all right, so we have linear, we have trigonal planar. What else, guys? After trigonal planar, what else do we have?
Tetrahedral.
Tetrahedral, then? After
trigonal bipyramidal.
Yes, trigonal bipyramidal. And then next?
Octahedral.
Yes, lastly we have octahedral. Okay, those are for electron geometry. Okay, and then we have molecular geometry. So basically molecular geometry is based on electron geometry, based on electron group. Okay, all right, so once you have the Lewis structure and you have identified the electron geometry, okay, you transform your Lewis structure just now into electron geometry sheet. Okay, you transform into electron geometry sheet, and then you identify the molecular geometry. You have to draw based on electron geometry first. Then only you would be able to determine the molecular geometry. Okay, all right. So if I were to, maybe you can have a blank slide here. Okay, if I were to conclude the Vesper, okay, and then how I would encourage you to draw all the electron geometries. Okay, katakanlah Vesper kan. Okay, Vesper, and then we have electron group or electron bond. Electron group or electron bond. Is it electron group ataupun electron pair? Sorry, electron pair. Electron pair can be in the form of bonding pair, or it can also be in the form of lone pair. Okay, electron is either electron pair ataupun electron group. Okay, regardless, it's basically the same lah. Okay, so we have electron group, and then we have the electron. This is electron group. This is electron geometry. Okay, and then this is you punya drawing lah. Okay, how you should draw, how you should represent your electron geometry and molecular geometry. Okay, all right. The 5 basics electron group. Sebab saya highlightkan the electron geometry here. Okay. For molecular geometry, what you need to do is to replace, okay, the bond with the lone pair at the same position that you have drawn just now. Okay, contoh-contoh. Okay, so electron group, katakanlah kita ada 2 electron group. Okay, so we have 2 electron group. So example, we have AX2. Okay, so this is in linear shape. Linear shape. So how do you draw the linear shape? Okay, linear is simple. Okay, all right. So this is the electron geometry. So remember, for the electron geometry, you are focusing on this electron group. For the drawing, okay, you are focusing on the atom. This is the molecular geometry. Okay, electron geometry is about the electron group. The molecular geometry is apa nama tu? Sepatutnya bukan buat kat sini. Saya patut buat dekat sini. X. Okay. Right, so this is for electron geometry. Okay, jangan confuse pula. Saya tengah cakap electron geometry ni sekarang ni. Geometry. Okay, and then next we have 3 electron group, which is AX3. So it is by right should be in trigonal planar, because that is the least repulsion that they can experience, all the electron group. Okay, so it should be in trigonal planar. The name of the shape, the name of the electron geometry, and then how do you draw the electron geometry? So I would highly suggest you to draw this way. So this is what we call trigonal planar. Okay, trigonal planar. And then kalau molecular geometry focus on the atom saja. Katakanlah dia ada lone pair, then replace one of the bond here with lone pair. Okay, replace the bond with the lone pair at the exact same position of the bond. Okay, jangan tukar, jangan sengit ke apa. This is our guideline. This is our guideline. Okay, so if you have lone pair, if you have 2 lone pair, 3 lone pair, and so on, once you have identified the position, okay, replace the bond with the lone pair. Katakanlah dekat sini kan, we have the lone pair here kan. So we have lone pair kat sini. So padam the X ni, ignore the X and then remove this one. Remove the bond. So that will be your molecular geometry later on. So molecular geometry will be bent. Okay, so that is what I meant by you need to use only the same, you need to use the same drawing, the same electron geometry in order to have your molecular geometry. Okay, so you tak payahlah nak pening-pening nak macam nak imagine the band tak payah. Okay, alright. So if we have 4 electron group, that means we have AX4. Okay, so AX4, so it should be tetrahedral. Okay, so this one I would suggest you to draw this way. Okay, ni tadi saya kecilkan. So this is a planar and then tetrahedral. Okay, dia ada 1 dekat atas, 3 dekat bawah. Okay, this is slightly angled. Okay, jangan tegak dengan yang atas tu. Nanti bila you buat tegak, you have higher tendency to state that the bond up there and dekat below tu you akan kata 180. So that is wrong. Okay, so the bond here, the angle bond between this one and this one is 109.5. This one up here again with this one is 109.5. Okay, dia macam saya tunjuk dekat model tu. It's actually the same. If you rotate the molecule, you will see the bond angle. Okay, the bond angle is actually the same. Okay, right. So this is 180 and this is 120. This one is 109.5. Okay, this is for tetrahedral. Okay, so the electron geometry. If I were to, patutnya kan saya buat macam ni tau. This is for molecular geometry katakanlah. Kalau electron geometry, saya tak tunjuk X tu. Okay, I should not show the X. Ya Allah, ya Rabbi. Dia sepatutnya begini. Saya patut tunjuk macam ni. This is the electron geometry and this is the molecular geometry, guys. Molecular geometry, you have the X. For electron geometry, you don't have, because we are focusing on the electron group. Okay? Tapi tak apalah, because saya dah cakap, saya buat sambil saya cakap. So patutnya by right you should have understood that lah. Okay? Banyak kali dah saya cakap, for the electron geometry, you are focusing on the electron group. Apa nak buat tadi? Okay, next. Number 5, if we have 5 electron group, that means we have AX5. Okay, so it should be trigonal bipyramidal. Okay, so remember for trigonal bipyramidal, it is special because it has two bond angle. Okay, so we have the equatorial part and the axial part. For the equatorial part, the bond angle, okay, for all the position, all the electron group at the equatorial part, it should be 120. Okay, all right. So how do you draw it? So I would suggest you to draw this way. Okay. Okay, go for the orang kan. Yang ni saya suggest orang kan, yang orang macam apa, orang lidi tu. This one orang lidi ya. Begini. Okay, alright. So identify the equatorial part ataupun the axial part. So look for the axial part. So the axial part will be the axial position would be the straight line, the linear position of the electron group, which is this one. Okay, alright. Equatorial is this one. Kalau saya tukar, this one is the equatorial position. Okay, alright. So if you were to identify the bond angle, so the equatorial part here is 120. This one also is 120. Okay, and same goes to this one. Kalau axial part, axial and equatorial. So this is equatorial, right? And this is axial. So this one would be 90, guys. Okay, that one will be 90. If you were to represent axial and axial, so it will be 180. Okay, from this one to here. So this is 180. But normally we will go for axial and equatorial. But you should know lah. Okay, please take note that between axial and axial it is 180. If there is no lone pair, guys. If there is no lone pair. We are talking about electron geometry. Lagi sekali saya cakap. Okay, molecular geometry, that means it can be different from the electron geometry. Okay, right. So last but not least would be our 6 electron group. Okay, and then we have AX5, AX6. So it is known as octahedral. For this one, I would highly suggest you to, before I forgot. Okay, kalau you nak place the lone pair, remember for AX5 for trigonal bipyramidal, make sure that you place it on the equatorial position. Any of these three first. Okay, you must place on any of these three first. Okay, do not place the lone pair on the equatorial, on the axial position. So you must place the lone pairs. If you have 1, 2, 3 lone pair, so all of those must be placed on the equatorial position, which is the blue circle bond ataupun electron group that I have shown here. Okay, please take note on that. Okay, guys. Okay, AX6. So for this one, I would suggest you to draw begini, macam bintang ke apa nak cakap. Buat straight line, okay? So up here will be straight line with the bottom, the one down here, okay? And then this one should be straight line with this one. And this one should be straight line with this one. Okay? All right, so this is your octahedral. Okay, so if you want to go for the molecular geometry, so this is how you should, your drawing should look like. Okay, so this is in conclusion of the Vesper theory that we have learned in previous lecture. Okay, all right, so we have discussed about checkpoint 13 if I'm not mistaken. Okay, so this one, ni saya komen kan hari tu kan, dia you kena slanted. Okay, this one saya highly suggest to you sikit macam ni. Okay, alright. Boleh macam ni if you are focusing on the the front view, you flat kan dia, you see this one lah. Tak, in fact you tak nampak pun begini kan. Boleh ada possibility nak nampak beginilah, tapi to be exact lah. Okay, to be exact, kita tak boleh nak exact sangat because after all this is 2D kan. 2D dia limited sikit compared to 3D, 4D and so on. Okay, alright. Tapi I would highly suggest you to draw this way rather than this way, straight line dekat situ. Because kenapa? I've seen student, okay, when they try to label the bond angle, okay, dia buat macam ni, this is 180, this is 109.5, which is wrong. Okay, because based on dia punya drawing, dia nampak straight. It's not as simple as that. Dia tak straight, dia sebenarnya angle. That is why I would highly suggest you for this bond kat sini tu, make it angle. Okay, dia jangan nampak straight, because straight you have the tendency to wrongly lah identify the bond angle. Okay, alright. So in last lecture, I have told you to complete this checkpoint 14 and the rest of the checkpoint that we have learned. The rest of the checkpoint that we have learned, that we have in our last lecture. Okay, so I hope and I assume, that everybody has completed the checkpoint. Okay, all right. So question 14, checkpoint 14, question 1. Predict the molecular geometry of the following species using the Vesper theory. Okay, so you have to complete. You have to draw the Lewis structure. Okay, you have to go from scratch. I mean, from basic. Okay, you have to have the Lewis structure correctly. Then you go for electron geometry. Okay, identify the electron geometry. You have to draw based on the electron geometry that you have identified just now, and then only you go for molecular geometry. Okay, all right. Okay, so this should be your drawing. Okay, this should be your molecular geometry. Again, this is PCl3 is tetrahedral. The electron geometry is tetrahedral, guys. Okay, even though the question did not ask for the molecular geometry, did not ask for the electron geometry. Itu tak, dia tanya molecular geometry. But it's the process, okay, in order to get molecular geometry, you need to know the electron geometry. Memang proses dia begitu. Okay, alright. So maybe we can try I3 minus. Okay, let's start from the beginning. So I3 minus, let's place the iodine first. Okay, so the iodine can be placed. So as you can see, there's the central atom is also iodine. Okay, so this is how iodine 3 minus looks like. Okay, because it is an ion, so please place the bracket and also the charge. Okay, please place the bracket on also the charge on your skeletal. Okay, so once you have this, kita calculate. Okay, let's start from the beginning. So iodine, we have 7 valence electron times with 3, so we have 21 electron. Okay, don't forget this is an ion. That means kita kena tambah atau tolak. Okay, in this case we have to tambah because it is an anion. Dia adalah an ion, bukan cation ion. Cation ion we have to tolak. For an ion kita kena tambah. As you can see, the value is 21, which is odd number. Okay, supposedly it should be even number, except for odd electron species, the exception last time. Okay, alright. So this one kita kena tambah 1 electron because of the charge. This is the charge of the ion. Okay, so total up we have 22 electrons. So 22 electron, kita minus the bond first. So how many bonds we have here? So we have 2 bonds. 2 bonds times 2 times 2. Okay, because we want to know the electrons. So we have 4 electrons. Okay, so we have used 4 electrons. So minus this one, we have 18 electron left. Okay, so this 18 electron will be placed on the terminal first. Okay, kita octetkan the terminal first. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so we have used 12 electron already. So we have 6 electrons left. This is for bonding electron. Sorry, belum. This is for bonding electron. This is for terminal electron. Okay, on the terminal atom. Alright, so we have 6 electron left. Okay, so this 6 electron left will be placed on the central. If there is balance of electron, that means we must place the remaining electron on the central. Kalau ada baki, tak ada baki, then as it is. Okay, and then you may need to check. Okay, if it is still not octet, that means you have to consider for the double bond or triple bond. Okay, all right. Okay, in this case we have remaining. So all the 6 electron will be transferred to ataupun will be placed on the central. Okay, so we have used all the 6 electron. This is central electron. So we are now, okay, left with 0 electrons. Okay, this is good. Maksudnya kalau dah 0 tu, it shows that we have used all of the electrons. Okay, alright. So this is your Lewis structure. Okay, check dulu. Lupa nak check the octet. Okay, so this iodine is now octet, the terminal one. And the center, as you can see, it is more than octet because it has 1, 2, 3, 4, 5. 5 times 2 is equal to 10 electron. Okay, all right. So it's okay because iodine is considered as expanded octet. Let it be. Jangan panik pula. Kenapa ada 10 pula ni? Because iodine is located on period 4. Okay, it can expand if needed. So in this case, this is what we call the central is considered as expanded octet. Okay, so let it be. Jangan panik pula ada more than 10. Okay. Now moving on, we have so this is again apa tadi nak cakap? We have 10 electrons kan? So this is expanded octet. Okay, so this is the Lewis structure. Baru kita complete the Lewis structure, guys. Okay, next step. So this is the first step. Second step is to identify the electron geometry. Okay, so the electron geometry in this case, kita kena focus on the central. Okay, focus on the central. So the central now, kita kena, we have to calculate the electron group on the central. So we have 10 just now kan. We have 10 electrons ataupun we have 5 groups, sorry. Kita ada 5 group. 1, 2, 3, 4, 5. Which consists of 3 lone pairs and, 2 bonding pairs. Okay, 3 lone pairs and 2 bonding pairs. Okay, so this regardless, there's still 5 electron group. So for this one, it should be, if we have 5 electron group, so what will be the electron geometry, guys?
Trigonal bipyramidal.
Yes, just namakan je dulu. Okay, trigonal bipyramidal. Okay, so once you have identified that, third step, I would recommend you to, bukan recommend, maksudnya you kena buat trigonal bipyramidal, then you go for drawing, baru you draw, okay, so that you could determine the molecular geometry later on. So you have to draw based on trigonal bipyramidal. So like what I have suggested to you just now, draw the trigonal bipyramidal shape, macam yang saya tunjuk tadi, yang this one tadi, mana? Yang this one. Yep, this one. Okay, trigonal bipyramidal bintang tadi. Right, so tadi tengah-tengah I. Okay, buat je 5 bintang tu. Buat je, this is our guideline. Okay, alright, so we have I. So this is equatorial. Remember, please identify the equatorial position first. Okay, so we have 3 lone pairs there. So make sure, siapa yang I ni nak duduk dekat mana? You mesti akan tanya macam tu. Okay, you mesti akan wonder, so, okay, I ni nak duduk, kan ada banyak bond kat sini, banyak electron group kan. So where should we place the I? Before you place the I, you kena take note that the lone pair should be placed on the equatorial position. So equatorial, which is here lah. Place all the equatorial here. Okay, that means the I should be placed on the axial part, which is here, guys. Okay, kalau you tak nak padam, antara satu-satunya, leceh kan nak padam, you buat bulat macam ni. Buat bulat gini ya. Padam lagi cantik lah, okay. Sebab dia tiba-tiba ada benda ni kan. Buat bulat. Don't have this. Tak ada bond tu dah eliminate. Okay, make it closer. Okay, make it closer. Adjust balik. Alright. Okay, so this is the electron geometry now. Then lastly, we would name the molecular geometry. So you have drawn it. Okay, you have drew it and then you identify the molecular geometry. So in this case, it is linear, guys. Nampak tak linear? Okay, so it should be linear. Okay, they should be linear lah. Nampak tak? So examiners pun okay. They mention that the the molecular geometry is linear and it is proven based on your drawing. Okay, based on your shape that you show. Okay. So itu saya tunjuk contoh mana you start from scratch and then you end up with the molecular geometry. Okay. Even though soalan tak tanya pun the Lewis structure, but it is understood. Yang you kena start from Lewis structure, the correct Lewis structure. Okay. So if Can you imagine if you got it wrong? That means everything will be wrong lah dekat bawah tu. Okay, so mungkin you tak lah 0 tapi you akan dapat markah kesian lah. Okay, that we call ECF, error carry forward, markah kesian, which is of course lah way less than the total mark. Okay, the total mark is 5 katakanlah, maybe you dapat 2 atau sometimes 1.5. Depends you betul ke tak ada part-part that apa yang required in determining the molecular geometry. Okay, so this is linear that we have tried just now. Okay, alright. So this one, okay. For C2H4 ni dia special sikit. As you can see, because dia ada 2 central guys. So this is considered as 2 central guys. Okay, this is considered as 2 central. Patutnya buat yang ni tadi. Okay, this is considered as 2 central because dia ada 2 central guys. Okay, alright. That means you have to focus for each one of them. Okay, focus for the first central. So what would be the, from your drawing katalah you akan dapat begini kan. You akan dapat begini normally. Okay, in this case you have 2 central. Central 1, central 2. Sebab dekat tengah dia tu ada 2 and then these are all terminal. So these 2 are considered as central. Okay, so these 2 are considered as central. So kita kena buat style 2 central lah. It should be, we have 2 central, that means we have 2 electron geometry and we should have 2 molecular geometry. It's just that for this one dia sama kan. Okay, so how do you identify for the first central? Focus on the first central only. Okay, ada berapa electron group on the first central? 1, 2, 3. Okay, so C1, the electron geometry is trigonal planar. How about C2? C2, okay, focus on C2 only. Nak buat color apa dah ni? Buat color pink. Okay, buat color pink. Okay, C2. So how many electron group on C2? So 1, 2, 3. Dia share kan yang ni kan? Okay, so C2 we have trigonal planar as well. Okay, and then the best part is how do we draw? Since we have two central. Okay. Tambah slide kot. Okay. So since we have 2 central just now, kita kena transform dia kan. C1, C2, trigonal. This is the electron geometry, okay? C2 is also trigonal planar. Okay, next step. Remember, next step after we have identified the trigonal planar, the electron geometry, we have to draw based on the electron geometry that we have here. Okay, alright. So, macam mana saya suggest tadi, trigonal planar, you akan buat begini kan? This is trigonal planar kan? This is only for the first central, betul tak? This is for first central. Okay, for the second central, katakanlah you boleh pilih mana-mana, tak kisah mana-mana bond pun. Kata saya pilih yang this one, okay? For the second central, kita connect them first. Okay, connect them first, okay? And then make sure you draw the second central ni with trigonal planar geometry. So kata this one is the connected one kan, ada double bond kan, lupa. Okay. So here macam mana nak bagi nampak dia begini, dia punya shape dia tu. So kata kalau this one yang tegak, so dia begini. Nampak tak trigonal planar shape tu? Okay? You still nak, sebab you imagine dia pusing kan. So regardless whatever dia punya position pun, it should be in trigonal planar shape lah. Okay, so beginilah rupa trigonal planar. Ini trigonal planar, this is also trigonal planar. Okay, so this is just based on drawing dulu and then baru kita go for molecular geometry. Betul tak? Again sama juga for molecular geometry, C1 is in, ni kita consider as a whole lah. Kita consider as a whole. Ataupun you can also focus on the C. Okay, tapi by right dia adalah satu set kumpulan. Katakanlah kita imagine dia sebagai A macam tu. Okay. Ataupun paling senang you focus on the central lah. Okay. So this is the central. So dia adalah trigonal planar juga. After all, dia tak ada lone pair kan. So kita boleh expect that the electron geometry should be the same as molecular geometry. Okay? Right. Yep, this is... Okay, any questions so far? Senyap je kat situ. Any question guys?
Madam,
So far okay ke?
yang kan dia ada yang dua central tu kan. Kalau macam tu, dia memang dia ada tak possibility untuk dia ada lone pair juga?
Ada?
Macam satu lone pair, satu tak ada. And kalau ada, kita kena provide dua answers ke?
Dua answers? Macam mana dua answers? Macam ni juga C1, C2 tu ke? Yes, 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 yes. Okay, katakanlah apa contoh, yelah, not all molecules tak sesimple as what we have in our checkpoint here. Okay, some molecule are very complicated dan besar-besar. Okay, so how do you draw those molecule? So you kena tahulah dia bukan just macam ni, ada satu je central. Memanglah ada molecule yang simple-simple macam ni, but we do have molecule that is bulky, that is apa nama tu, complicated kan. Maksudnya central dia ada banyak. We can imagine that we have more than one central. So how do you determine? Dia mesti ada dia punya shape dia sendiri. Betul tak? So that is how this, okay, just now yang saya tunjuk tu is how we determine the shape for each central. Okay, kalau katakanlah you ada A, B and then ada C banyak kan, then you go for, katakanlah dia macam dia ada banyak, dia ada A, B and then C central, and then you go for, okay, the A, what will be the electron geometry for A, tetrahedral for example, and then B, what will be the electron geometry for B, okay, linear for example, and then for the molecular geometry pun you have to have 3 molecular geometry for by right for each central lah. Okay, for each central. This is just to highlight, but normally for our syllabus we would ask for normally we would ask for one central only. But sometimes, okay, we do have this type of question yang mana pakai carbon tu. Tadilah ni this one. We do have this type of question. Okay, so kalau everything yang ada dalam lecture notes tu ada possibility to be coming out in your exam. Kalau dia tunjuk ada 2 central kat sini, that means there is high possibility that it will be coming out in the exam. Okay, ada possibility yang dia dah serabut kan kat sini kan. Okay, change to blue lah. Okay, ada possibility that this is trigonal planar, but this one linear ataupun tetrahedral ke whatsoever kan. Boleh imagine tak kalau C5H10 looks like? How does this apa nama structure looks like? So you kena buat 5 lah. Boleh imagine ada 5 central kan, because we have 5 carbon there. That means you have to have 5 electron geometry. Then you have to draw, and then you have to identify the molecular geometry. Okay? Kalau dekat sini, kenapa jawapan dia tu tunjuk begini, dia macam senang ni hidup, trigonal planar macam tu. Okay? Sebenarnya dia identify dua-dua. So this molecule is considered as what we call symmetry. Okay? So C1 is trigonal planar, C2 pun trigonal planar, so dia trigonal planar. Okay, tapi sebagus dia you kena buat macam ni. C1 trigonal planar, C2 is also trigonal planar because there are 2 central. Okay? Right. Soalan ada lagi? Tak ada? Okay, right. Question 2, choose the molecule that exhibit tetrahedral molecular geometry from the following species. Explain your choice. Okay, so you have to identify which of these 3 molecules exhibit tetrahedral molecular geometry. So in order to identify that, you have to draw for all of them. Okay, you have to draw for all of them and then identify whether the molecular geometry is tetrahedral. Okay, identify. So dia punya step. Then draw lah 3-3, okay. You can see, so this is, kita cut short dia terus, okay, tapi step dia like what I've shown to you just now. Okay, so silicon tetrachloride. So as you can see, this is how. Again, saya ada masalah dengan benda ni, saya suka dia begini. Okay, this one also. This should be, betul tak? Because this is NH4+. Okay, alright. Okay, so these two are tetrahedral. This is also tetrahedral, but this one is not tetrahedral. Jangan base awak nampak ada 4, awak kata dia tetrahedral. Okay, so that is totally wrong lah. You ada masalah lah dekat situ bila you kata this one is tetrahedral. This is not tetrahedral. This is square planar molecular geometry. Okay, the electron geometry. Okay, walaupun dia tanya soalan macam itu, you kena practice lah. Okay, so this one, the electron geometry is octahedral. How about the molecular geometry? It is square planar. Okay, menggunakan drawing yang sama yang macam ni yang saya ajar tadi. Sorry, buat straight line. Okay, straight line. Dia pair. Atas, bawah. This is square planar. Okay, so the answer should be SiCl4 and NH4+. Okay. Right, and then, okay, punyalah panjang untuk kita punya checkpoint tu. Okay, alright. And then we learn about polarity. Okay, after we have learned about Vesper, we have polarity, because polarity is based on molecular geometry, guys. Okay, it's based on molecular geometry, because later on we're going to learn about hybridization. Hybridization depends on the electron geometry. So polarity, please remember that polarity based on molecular geometry, hybridization will be based on electron geometry. So those two are very, very important. You tak boleh hafal je lah molecular geometry or electron geometry. Okay, if you go for any of these two, instead of both, you kena cover, you kena master, you go for only one, that means you lost mark for hybridization lah later on. Okay, alright. Okay, so for the polarity, the most important thing you have to have the dipole moment. Okay, the arrow, this is what we call dipole moment. So it shows the direction of the unequal sharing of the electron. Okay, so dia dipole, di means dua, pole means kutub. Bila the unequal sharing, okay, the dipole will be formed. Dia tak share sama kan, so dia tertarik. Okay, it is pulled toward the other atom. Okay, so that means yang seorang lagi yang aku dah elektron dah tertarik ke sebelah sana, so that side would be slightly positive, this one would be slightly negative, because the electron is now pulled towards itself. Okay, so to represent this dipole, we have this dipole moment. So it shows that when you have dipole moment, it shows that the bond, guys, I'm talking about the bond, okay, not in terms of the molecule, the whole molecule itself. Kita ada dua, okay, the bond itself and the molecule. Okay, the bond itself and the molecule. So the bond, if we have this unequal sharing ataupun different electronegativity, therefore we should have this dipole moment, and the bond is therefore polar. Okay, the bond is polar. Okay, alright. So this is simple molecule like HCl. Okay, obviously kalau this bond is polar, and then molecule dia tu pun polar lah. Dia tak se-complicated that what we have learned for complicated molecule. Complicated molecule taklah complicated. Complicated means it has one central. This one kan dia dua-dua terminal. Betul tak? This is what I call simple molecule. Kalau later we have central and then we have terminal atom kan, ada banyak terminal atom kan. So that is slightly complicated compared to HCl. Okay, compared to Cl and Cl. H2, okay, so dia slightly complicated. That means itu yang kita akan ada polarity of the molecule. Polarity of the molecule. Okay, But whatever is the polarity of the molecule depends on the dipole moment. This one sebab kita dah ada central kat situ. Kita dah ada central kat situ. So first step is to draw the dipole moment. This is what we call the dipole moment for each bond. Okay? For each bond. You kena draw. And then baru you go for vector punya style. Vector punya style. Ada baki tak? Ada balance tak? Bila ni opposite direction and same magnitude kan? Opposite direction but same magnitude, therefore it can be cancelled out. It can be cancelled out. Okay? So dia tak ada baki. The net dipole moment tu yang vector bersih tu, dipole moment bersih. Okay? There's no net dipole moment kan, because it has now cancelled out because dia both adalah oxygen. So imagine kalau dia adalah fluorine ke any other atom than oxygen, of course dia akan ada dipole moment. Dia ada arrow lah towards fluorine because it's no longer having the same magnitude. Okay? You guys dah belajar vector kan sebelum ni kan? Pernah belajar kan?
Pernah.
Benar kan? So patut dah ada knowledge lah on how vector works. Okay? How do you determine the vector? So if katakanlah all of these are fluorine kan, if any of these atoms, terminal atoms, being replaced with something else, automatically it will become polar. Sebab dia tak cancel out. Walaupun dia different direction but the magnitude is not the same. Like I've mentioned in our previous lecture last time, katakanlah someone is pulling me to the right, the other one is pulling me to the left. If they both have the same power ataupun mass ataupun energy, okay, everything the same, so that is what we call magnitude. Okay, and then dia menarik saya ke arah yang berlawanan. Will I be moving to any of these two direction? No, I will not be moving. Saya tak akan move. Sebab some power. Paling pun saya punya tangan tercabut. Okay? If itu yang maksudnya semua ni, maksudnya kalau semua adalah F ataupun semua adalah F, sebenarnya kita nak highlight the magnitude. The magnitude is the electronegativity's value tu lah, our reference tu. Imagine if the person on my right hand side ni adalah stronger than my left hand side punya yang tarik saya ni. Okay? Opposite direction still dia akan opposite direction tapi I will be moving towards the right. Kenapa? Sebab orang yang tu lebih kuat. Ataupun orang yang kiri tu lebih kuat. Mana-manalah salah satu. Nak highlightkan that they have different magnitude. Okay, so saya akan bergerak. Bila bergerak tu, that is what we call net dipole moment. Bila dia dah, kita kira vektor dia tu, dia ada baki. So baki tu dia punya direction is to the right. Apatah lagi kalau kanan tu dia tolak saya ke kiri, yang kiri tarik saya ke kiri. So saya akan bergerak ke mana? Adakah dia cancel out? No. Okay, I will be moving to the left. Tu maksudnya dia ada vektor yang di akhir final vector tu. Okay? Alright. This one. So nampak tak dia draw in terms of molecular geometry. So to solve for polarity, first step we will be looking on your molecular geometry. Are you using the correct molecular geometry? That will be your first mark. Second mark, we will be counting for your dipole moment. Okay, dipole moment tu ada tak? Untuk setiap bond, you should have dipole moment. If there's missing, that means you hilang markah terus, walaupun yang lain you buat. Okay, and then not to forget for the dipole moment, make sure that the direction is correct. So it should be, in this case, it should be pointing to Cl kan? Tapi you buat pointing to carbon. Salah juga. Okay, alright. And then last but not least, is there, you have to determine whether dia polar or non-polar. Kalau dia polar, dia kena ada this. Tak kisahlah dia ke bawah ke atas. Again, it is based on your drawing. Okay, your apa nama benda lah ni? Your geometry lah. Okay, your geometry. As you can see, nampak tak? Ni semua Cl tiba-tiba ada satu hydrogen. Of course, it will not be cancelled out. Dia akan ada baki vector tu. Bila combine all the vector, okay, there will be final vector that is pointing downward. Sebab apa? Sebab semua tolak ke bawah ni. Okay? Right. Okay, so we have done for H2O last time. Kita dah determine. So I hope by now you should know why H2O is a polar molecule. Kenapa dia polar? Why is that polar compound can dissolve in polar? It can dissolve in water because water itself is a polar molecule. Polar means you have dipole and then you have this dipole moment. Okay, so it will attract ni nanti kita akan belajar in intermolecular forces. So this is negative ends kan. So it will attract the positive end from the other, for example, ionic compound ke when it is dissolved in water. Okay, dia akan attract the positive. So bila ada this interaction, so then only we can say that it is dissolved ataupun solubilized in water. Okay, alright. So this is mu is not equal to 0 sebab dia ada this dipole. Okay. Predict whether the following molecules are polar or non-polar. Okay. So this is the Lewis structure given. The Lewis structure has been given to you. Okay. Dah bagi Lewis structure. But you have to transform. Don't forget. Jangan ingat, oh inilah dia punya geometry. No, it's not. Okay. You have to transform into electron geometry. Buat sama step macam awal-awal tadi. Cuma kita akan ada tambahan. After we have the molecular geometry, we have to determine the polarity, guys. It's just that kita tak payah start from scratch lah because we have this already. So kita determine 1, 2, 3. So this is the electron geometry should be trigonal planar. Betul tak? Okay, transform this Lewis structure into trigonal planar shape. So N. Okay, so here is O, here is Cl, then this is double bond, lone pair lah. Okay, ignore the lone pair because we are focusing on the molecular geometry. Okay, so this is what is the molecular geometry, guys? You dah draw betul lah ni. Apa molecular geometry dia?
Band.
Yep, it's band. Nampak tak band shape? Ignore the lone pair, so it is band. Okay, alright. So dah settle Ini dah settle. This is what we have learned in Vesper. Okay, so this is the application. Okay, now nak proceed to polarity. Okay, so for polarity, in order to determine whether this molecule is polar or non-polar, kita kena go for each bond. Dipole moment for each bond. Okay, nitrogen and oxygen. Which one is more polar? Which one is more electronegative? Okay, oxygen is more electronegative. Kita ada values kat sini 3.5 and nitrogen is 3. Okay, that means okay, buat color lain. Okay, nitrogen, so this is slightly positive kan? This is slightly negative. Okay, so it should be pointing from nitrogen to oxygen. This is what we call dipole moment. For each bond. Each bond tu, faham tak? Bila double bond tu considered sebagai satu lah ya. Jangan pergi buat double bond ada dua ni. Oh kena buat lah. So ada dua macam ni. Jangan. Kan kita dah kata double bond tu kita considered sebagai satu set. Triple bond pun sebagai satu set. Okay. So jangan pergi buat ada dua pula dipole moment for double bond ni. Okay. Alright. Okay, for nitrogen and Cl, guys, tengok dia punya electronegativity. Oh, they have the same electronegativity. Okay, they have the same electronegativity. That means they do not have dipole moment. Betul tak? Dipole moment ni akan ada bila ada kutub tu, ada positif dengan negatif kutub tu. Tapi since they have the same electronegativities, that means, apa maksud is same electronegativities tu? Dia share equally. Dia share equally. Maksudnya dia tak tertarik towards Cl or nitrogen. Okay? Alright, so that means dia tak ada dipole moment. So this bond kita kata polar. The bond is non-polar because they have the same electronegativity. Contoh macam Cl dengan Cl kan. So this is also non-polar because they have the same electronegativity, guys. Okay, alright. So kat sini, is it polar or non-polar? The answer will be polar lah because dia ada somebody tak yang boleh cancel out this dipole moment. There's no dipole moment except for this one. This is the only dipole moment. Obviously, there will be no cancellation there. Okay, so the net dipole moment will be pointing here. So this is the net dipole moment. Again, it depends on your drawing, your geometry. So don't worry, kalau tak sama dengan saya, kita akan tengok. Kalau band shape you tu macam mana? Menghadap ke atas ke V ke atas? Ataupun V ke tepi ke? Bugit. Okay, so kalau dia ke tepi, that means dia akan the direction of dipole moment will be different lah from this one. Okay, alright. So don't forget. Therefore, the molecule is the net that ataupun the mu is 0. Mu is not equal to 0. Okay, so you have to have this. This is the most important thing. Okay. So the net dipole moment does not cancel each other ke apa benda, does not cancel. Molecule is polar. This is important. Conclude tu pun important. Kena conclude walaupun dah nampak obvious. Ada benda ni polar lah. Tak faham. Okay, jangan assume examiner faham sendiri. Kita memang pantang kita bila student assume kita faham sendiri. Kita tak faham. Okay, kita tak faham. Kita buat tak faham. Alright. Okay, so begitulah cara dia you go for this one. Okay, this is tetrahedral in shape because kenapa? 1, 2, 3, 4. You have 4 electron groups. That means you have to draw based on tetrahedral shape. Okay, so dia ada satu je lone pair. Normally, if there is lone pair, normally it will be polar lah, except guys, okay, except for octahedral punya shape, square planar dengan linear. Okay, and also trigonal bipyramidal kan kita ada linear shape tu kan, dia ada lone pair tapi dia still what do we call that, dia still polar. Dia still non-polar. Okay, octahedral. Sebab kita based on electron geometry kan, molecular geometry. Octahedral terbitan dia square planar and linear, guys. Even though these two has lone pairs, okay, but they are still non-polar and also trigonal bipyramidal. Okay. Apa terbitan dia? Linear. Yang linear tu dia akan, walaupun dia ada lone pair, but it is still non-polar. The rest, okay, ni tips. Saya nak bagi tips ni. Okay. The rest for all the geometries, if there is lone pair, satu lone pair pun, dua ke, ada je lone pair, it become polar. Katakanlah you tak mahir vector kan, ada students dia tak mahir vector, tapi dia boleh predict. Okay, the tips is look for whether dia ada lone pair ke tak lone pair. Except for this structure, okay, except for this geometry. You kena be careful. Okay, other than this geometry, that means dia akan jadi dia akan jadi polar. Dia ada je lone pair, dia terus jadi polar. Tu nak cepat lah, nak cepat. Okay. Yeah, you kena draw you have to draw the electron geometry, the molecular, yelah, you kena transform this to this. This is tetrahedral kan, but molecular geometry, electron geometry is tetrahedral, but molecular geometry it is trigonal pyramidal. Okay guys, trigonal pyramidal. Remember, we are focusing on the atoms part. Okay. Alright, so this is polar because they do not cancel each other ataupun the mu is not equal to 0. Therefore, the whole molecule combined, okay, combining all the vectors. Therefore, this molecule is polar. Okay. Right. So at point 18, CO2, OCS. Okay. Why CO2 is non-polar but OCS is a polar molecule. Okay. Both of them are both linear molecule. Tapi kenapa CO2 non-polar but OCS is a polar molecule? Bila draw baru nampak kan? So this is CO2. Like I said, they have the same magnitude. Katakanlah electronegativity dia 3.0 here, this is also 3.0, but they have different opposite direction. It will be cancelled out. Okay, but for OCS, turn out carbon dengan sulfur ni they have the same, see, the same electronegativity, guys. So dia tak ada, there's no dipole moment on this bond, no dipole moment on this bond. So we only have one dipole moment, okay, from carbon to oxygen. So there's no cancellation involved. So we have the net dipole moment pointing towards oxygen. Therefore, this molecule is polar. Okay, alright. So your answer apa? Jawapan you patutnya apa? Ni. This is the answer, okay? So because therefore they cancel. Okay, so this is for CO2. They have the same electronegativity. Okay, so and opposite direction. Therefore, it can be cancelled out. Okay, in OCS, the electronegativity of C and S is equal. Okay, thus the net dipole moment will be pointed to. Sebenarnya kan dalam exam, you tak perlu pun this statement ni. Ayo, hai. Okay, you just label je lah, label. Sebenarnya begini pun kita dah nampak dah, tapi you have to highlight lah. Okay, for OCS, there's no dipole moment on C dengan S. Obvious lah kat sini kan, sini kita nampak dipole moment ke sini. Okay, so understood, student ni faham. Okay, nampak ada beza this CO2 dengan OCS. You have proven that the OCS, why is it polar? Okay, due to the presence of only one dipole moment. So dekat situ you just highlightkan because there's no cancellation of this dipole moment. Situ saja. Therefore, OCS is polar. You tak perlulah ni. Okay, because you dah tunjuk kot, you dah draw the dipole moment. So why do we need this to explain further, betul tak? Okay, kita nak mudahkan you punya kerja lah. But if you can come up with this statement, by all means buatlah. Okay, kalau tak apa. As long as you have this evidence, this drawing, this geometry to prove your point. Okay? Okay, habis. Ada soalan ke? Just nice. 1 jam kita allocate for Vesper punya discussion just now. Okay, for all the checkpoints. Any question related to our previous topic, guys, before we proceed with valence bond theory and hybridization? Maybe kita boleh try ni lah, contoh kita dah buat I3 tadi kan, I3 minus kan. Kita nak determine the polarity of I3 minus. So how do we draw? How do we represent the I3 minus? Okay, cuba tadi kita dah draw sampai ke sini, betul tak? Kita dah dapatkan dia punya geometry just now. Kan kita place the iodine here kan? Ni lone pair kan? Okay. Alright, so guys, is this polar or non-polar, guys? I3 minus.
Madam, tinggal lagi satu I.
Sorry?
Tinggal satu I lagi satu.
Tinggal satu I. Sorry, tak dengar lagi sekali.
Nah, betul madam, betul.
Kan? Dipolar ke tak polar? Bercukup kan? 3 kan? I3 minus kan? Is this molecule polar or non-polar based on the structure given?
Non-polar.
It is non-polar because dia I dengan I dengan I. Okay, so dia share equally lah. Dia share equally. Okay, so bila dia share equally, that means dia dipole moment tu tak ada. Okay, there's no dipole moment. We cannot draw the dipole moment. Sebab they have the same electronegativity. So the molecule itself is non-polar. Okay, the molecule itself is non-polar. Okay, right. Tapi ni dia ion dia ion. So we know that ion they are polar because dia negatively charged. Okay, because the reason is they accept electron. Kalau based on this structure alone, dia tak polar. Tapi sebenarnya dia polar because it is ion. Tapi tak apa, don't worry about that because that is not covered in our syllabus. So you just buat based on what you have learned. Okay? Apa ke contoh square planar punya ni Square planar ke apa Okay, please remember if katakanlah you dapat AX. Nanti kita try buat ni lah yang ni tadi. Mana tadi? Square planar tadi. Nak buat yang square planar. Tadi jawapan saya tadi. Tadi lah mana? Oh, dekat ni. Dekat Vesper. Jom buat ni. Kalau dia nak electron geometry kan. Alright, for this one. Okay, alright. So this is your molecular geometry. You got square planar. So this is square planar. Okay, guys. Alright. So next, proceed to polarity, guys. Okay, for polarity, remember, you kena show the dipole moment first. Okay, the molecular geometry is correct. That means you got 1 mark there ataupun half mark. Next, you have to draw the dipole moment for each bond if there is any. Kalau tak ada macam I tadi tak ada kan, tak perlulah. Okay, so in this case dia ada sebab Xe dengan F. Check the electronegativity. Jom check. Check mana lah, jauh lah pula nak check. Mana nak check? Mana. Where is electronegativity? Aduh, tak ada actually. This one here. Okay, jom kita buat dekat sini. Okay, we have Xe just now. Straight line. Okay, straight line. So this is F. We have 2 lone pair just now, right? Okay, we have 2 lone pair. So the electron geometry is octahedral. The molecular geometry is square planar. Okay, Xe, alamak tak ada pula dekat sini. Penat-penat duk cari Tak ada, tapi okay, what do you think? Is Xe more electronegative or more electropositive than fluorine, guys? Respond, please.
More electropositive.
Yes. Okay. The more. This is. We have this type of question in final exam last time. Okay. So kita bagi Xe dengan fluorine. Student saja je. This is tricky part sebab apa? Student kata Xe is more electronegative than fluorine. Why is it? Kenapa? Because based on electronegativity trends across the period, it become more electronegative. Trend tu betul, tapi it is not applicable to group 18, guys. Group 18 is special because it's already octet. Okay, dia special, dia tak ada tendency to accept electron. Okay, so Xe sebenarnya dia positif. Okay, dia more electropositive sebenarnya. Dia tak ada, dia electron affinity is very low. Okay, electronegativity pun very low. Have no preference towards electron. Tak suka pun sebab dia dah already octet. So student akan buat common mistake student buat adalah this one is slightly negative, this one is slightly positive. Sebab based on trend. Tapi dia lupa that group 18 is special. So, you dah masuk dalam kita punya trap. Yes, kita akan bagi soalan-soalan yang macam tu lah. Okay, nampak macam direct kan? Tapi kat situ dia punya twist tu ada sikit ada kat situ. Okay, alright. So, terbalik dia XE should be slightly positive. This one should be slightly negative. Okay, so you boleh imagine lah sebab dia paksa xenon ni to form bonds kan. So this is very unlikely, but we still can force the reaction to occur. We have to put effort lah. Okay, because you know xenon come from group 18, they are all stable. Okay, dia tak nak buat reaction, tapi kita boleh push lah. Kita boleh paksa. Right. Okay, so do that first. Show the formation of dipole moment. Blue color. Okay, so this is negative, negative, negative. So it should be pointing towards fluorine. Okay, all right. So as you can see, we have two lone pairs. Even though dia ada lone pair, but this is still non-polar. Kenapa non-polar? Because they cancel each other. They kan straight line kan. Then they have the same magnitude. Fluorine kan. Lainlah kalau fluorine and then sini chlorine. Okay, dia tak ada same magnitude. Definitely dia akan polar. Okay, so this one can be cancelled out. This one with this one, because they are in straight line, okay, it can also be cancelled out. Sometimes ada student suka buat macam ni. Dia suka main angle. Saya pun dah faham angle tu macam mana kan. So, okay je nak main angle. So, macam biasa. Dia buat macam ni This fluorine with this fluorine. So, these two are angle. Dia macam tu. Dia angle. Dia V shape. Okay. So, dia ke sini dengan ke sini. So, can you predict the direction of the combined vector? So, it should be tukar color hijau. Okay, so this one kalau kita combine, dia akan dapat ke sini, tegak ke atas. Betul tak? And this one, if we combine these two, kita akan dapat ke bawah. Still, nampak tak? You dapat, at the end of the day, you still dapat straight line and these two can be cancelled out. Therefore, it is non-polar. Okay, provided that they all have the same magnitude. The same magnitude maksudnya the same electronegativity. If any of these four is different, tak ada, terus jadi polar lah. Okay, right. Okay guys, I hope that you understand what we have learned so far. So that kita boleh proceed to hybridization. Okay, maybe we can have 2-minute break. Okay guys, 2 minit. Tak ada soalan kan? Tak boleh nak lama-lama sangat sebab kita pun banyak lagi kita punya topik. Okay, saya nak pergi ambil air sekejap. Okay, so let's guys. Okay, are you guys ready?
Yes, madam.
Yes.
Madam.
Okay, all right. So this is another challenging subtopic. Okay, after we have Vesper just now, this is the last challenging subtopic. I'm talking about subtopic in topic 3. Okay, and then we are done. But we do have one more subtopic, but it's not as complicated compared to Vesper and also hybridization. Okay, all right. So okay, Bismillahirrahmanirrahim. May Allah is, okay, valence bond theory and hybridization, learning objective. So we have 3 learning objective for this subtopic alone. Okay, so make sure that you are able to cover all of these 3 learning outcome ataupun learning objective. Okay, right. Overlapping orbital. So valence bond theory. Okay, valence we know. It can be valence electron, it can also be valence shell. Basically, it's the outermost, okay, the outermost shell or outermost electrons. So that is valence. Bond, that means the electron sharing. Okay, so it involves valence shell and valence electron. So that's why valence bond theory. Okay, so the bond is formed for valence electron and also valence shell. Okay, it's a theory to explain the electron pair or covalent bond by quantum mechanics. Okay, so a bond forms when an orbital on one atom overlap with another orbital on the other atom. Okay, and then maximum number of electron in both overlap orbital is 2. Okay, so we need to have this valence bond theory in order to help ataupun to guide us on how the bond actually form. Okay, we do have Lewis theory. Kita ada Lewis theory. Okay, we know that they share electron kan in order to form a bond. But how about in terms of orbital? What happened to the orbital when they shared electron? Betul tak? Apa terjadi pada orbitals bila the electron is shared between the 2 atoms? So Lewis theories does not mention that, okay, for bond forming. So that is why we have this theory in order to help us to better understand what ataupun how the bond form. Okay, so bila bond nak form, what happened to the orbital? They actually overlap with one another. So we know that orbital kan dia boleh p orbital. Remember kita recap from topic 2, we have p orbital, we have d orbital, we also have s orbital. Okay, so how do they share electron? So basically the orbital, okay, imagine the electrons dia duduk dalam orbital kan, so they come closer to one another, okay, and they finally overlap. So bila dia overlap, the region that they overlap tu, region yang dia overlap tu is where the bond form. Dekat situ lah. So the electron tu kan seorang bagi satu kan. Alright, so they overlap. So at that region is the bond lah. It's actually the bond. Okay. So the number of electrons should present dekat region tu should be 2. Maximum it should be 2 electrons. Okay. So that is the basic idea of what valence bond theory is. Okay. Right. Moving on. Okay. So this is how orbital overlap in diatomic molecule. So H2, for example, H2 is a molecular compound. Okay. So we know that hydrogen, hydrogen, they have s orbital because hydrogen only has 1 electron. But in order to become duplet, it requires 1 more. Okay, so these 2 hydrogen, they come closer to one another in orbital S shape kan, bulat kan. Okay, they come closer and they overlap. So bila they overlap tu, the electrons are in this region. So this is what we call bond. Sebenarnya bond macam ni dia tak ada, dia elongate macam ni HCl. Dia bukan macam ni. This is just for representation so that we'll be able to understand better. Tapi in reality molekul tu dia are close to one another. Dia rapat-rapat because they share electron kan. You know that electron is very tiny kan. So they close. Dia bukan macam ni, nampak macam wow jadi bond panjang tu. Bukan, dia begini sebenarnya. They overlap macam tu, CLH. So can you imagine, okay, the size are actually very cutely ataupun dia very bulky guys tu. So kita mungkin having difficulties in imagining okay, how the bond actually forms. So that is why for the representation sake, okay, kita elongateskan the bond. Instead of the double electron kan, so we elongate them. Macam tu. Tapi jangan imagine dia macam tu dia sebenarnya bulat-bulat macam ni. Dia overlap begitu. Okay, alright. Okay, so that is between S and S orbital. We can also have S and P because hydrogen, we know that the electron is in S orbital. Fluorine, okay, fluorine kan datang daripada block P kan, and then fluorine punya last highest orbital highest sublevel is 2p kan, 2p orbital kan. So that's why the shape is actually lobe shape, cuping. Okay, so one electron from fluorine, one electron from hydrogen.
Madam.
Ya.
Nak tengok yang slide tadi tak?
Sorry?
Yang tadi nak tengok yang slide tadi. Hydrogen tadi tak?
Tak dengar slownya.
Boleh dengar
Siapa
tak?
tu?
Boleh dengar tak?
Tak dengar. Slow sangat. Saya lah tak dengar, tak tahu yang lain dengar ke tak.
Sekejap saya cabut.
Tak apa.
Now better. Okay.
Okay, aku nak tanya yang tu, yang kat diagram tu kan, SS overlap tu apa maksud dia tu?
SS overlap. Ni lah. Ni.
S apa?
S ni S orbital.
Oh.
Kan saya cakap tadi. Ni atomic orbital. S orbital, P orbital. SS overlap. So S orbital, hydrogen kan dia ada satu elektron kan. The only electron. So that electron is in S orbital kan. So what actually happened to the S orbital when they overlap? So this is how it looks like. Okay, so SS overlap. Kan dia cakap valence bond theory ni dia mention about atom, the orbital will overlap with one another. The orbital. So we have orbital dia banyak kan. Ada S, we have P, we have D. Kan? Okay, for example, hydrogen is in the electron is in S orbital. So that's why they represent using spherical. Okay, using bulat ni lah. Okay? Alright ke? Faham tak? Ya.
Dia punya arrow tu show direction of electron spinning ke?
Ya. Okay? To represent electrons, kalau Lewis structure we use dot. But in later on in hybridization kita still pakai orbital diagram, which is yang kotak-kotak yang line tu kan. So to represent that we have to show the arrow atau the arrow or to be specific is actually the spin of the electron. So it should be pointing upward ataupun downward. Okay, kita akan pakai ni arrow atas bawah tu lah. Tak pakai dot Okay. Any other question? Okay, tak ada Okay, proceed Okay. So this is S orbital, bentuk dia bulat. This is P orbital, bentuk dia begini. Yang kita dah belajar in topic 2 last time. Okay. Lupa pergi tengok balik. Jentik di dahi tu bang. Pergi tengok balik. Fluorine, kenapa fluorine dia macam tu? Because fluorine comes from block P. That is one thing. And then try to write the electron configuration for fluorine. The last sublevel, the highest sublevel ataupun the valence for fluorine. Okay, kita ada 2p. It's 2p5 even. Yes, 2p5. 2, 2, 3. Dia satu lagi elektron yang unpaired tu. So dia akan pair dengan this hydrogen, the electron from hydrogen. Okay? So this is for simple molecule macam biasa, simple, okay, they very straightforward, they basically come closer and then they overlap. Okay, how about molecule yang ada central guys, yang ada central then ada terminal, so dia ada sedikit complicated, okay, on that part. Okay, tapi basically the basic concept is that the orbital will overlap. Okay. Okay, a sigma bond. So we have two types of bond. So we have sigma and pi bond. Okay, you may be familiar with pi bond, but mungkin you tak familiar with sigma bond. Okay, so we have two common bond that can be formed between the two atoms. Okay, we have pi and sigma. So what is the difference between these two? Okay, a sigma bond result when the interacting atomic orbital points along. This is very important. Points along the axis connecting the two bonding nuclei ataupun end-to-end overlapping. Is how the bond is formed. Maksudnya how the orbitals overlap with one another. Okay, a sigma bond, dia punya overlapping is end-to-end overlapping. Hujung dengan hujung kepala dia overlap macam tu. Okay, later kita akan tengok pi bond. Okay, it can be formed between S dengan S, P dengan P, S dengan hybrid, okay, and so on. Okay, so sigma is the most common bond form. Normally, the first bond form, the first bond form between the two atoms. Okay, and they overlap end to end, hujung dengan hujung. Okay, contohnya, this is P orbital kan, this is P, this is also P, so when they come closer, they will overlap. So this is what we call pi bond. Nampak tak hujung, this end dengan this end. Okay, and the region they overlap tu is the bond. So the type of bond form is sigma bond. Macam ya, sigma. Okay, alright. Pi bond on the other hand, dia overlap parallel to each other. Parallel. Tadi end to end kan, kepala dengan kepala. But this one, they parallel, side by side. Okay, this is what we call sideway overlapping guys. Sideway overlapping. Contohnya between unhybridized parallel p orbital. So pi bond can only form between P dengan P ataupun D dengan D. Tapi D tu dah complicated lah. Normally untuk syllabus kita P dengan P. S tak ada. Sebab apa S tak ada? Sebab S after all dia bulat. Dia overlap macam mana pun still nampak sama. Okay, itu kita consider sebagai sigma. Dia tak ada pi. Pi ni maksudnya dia sideway sebab hydrogen macam hydrogen tadi kan, dia kan s orbital dia bulat. You overlap lah kat sini ke, kat sini ke, kat sini ke, kat sini ke. Okay, sisi ke, atas bawah ke, you still get the same apa nama tu overlapping. Okay, dia akan dapat kita consider it sebagai end-to-end lah overlapping because the shape of the orbital itself is spherical, dia bulat. Okay, but pi bond dia present for p orbitals and also d orbital. Okay, so dia boleh tapi it can also p orbital can also form sigma, boleh, tak ada masalah. But pi bond, okay, dia mesti daripada p orbitals ataupun d. Tapi syllabus kita cover untuk p. Okay, alright. So tadi just now we have this one, p dengan p overlap end to end. But for pi, dia overlap sisi dengan sisi macam ni lah. When they come closer to one another, jadi begini. So terlampau rapat kan? Nampak tak? Satu je. Dia ada satu. Dia share. Buat lagi sekali. So present the electron, dia boleh atas ke, dia boleh duduk bawah, tak kisah. After all, dia sentiasa moving. Okay? Tu yang dia elongates ni, Dia elongates kan. Okay? So this is what we call pi bond. Sebenarnya dia rapat macam ni, dia rapat begini. This is how close they are. Tapi to represent it better, lebih senang nampak, kita elongate kan. Nanti you akan tahu kenapa kita kena elongate kan bila kita buat hybridization later on. Okay, alright. So this is what we call pi bond. The interaction between parallel orbital is not as strong as between orbitals that point at each other. Therefore, sigma bond are stronger than pi bond. Okay, please take note that sigma bond is stronger than pi bond. Okay, so pi bond normally present in double bond and triple bond, guys. Okay, so normally the first bond formed between the two atoms will be sigma. Okay, the first bond dia kena sigma. Contohnya C double bond C. So this is sigma, this is pi. Dia mesti ada sigma. C triple bond C. Okay, sigma katalah kita place dekat tengah and then the rest are all pi. And then sigma can only form once. Satu je between the two atom. The rest are all pi. Okay, after all paling banyak bond dia boleh form adalah at multiple bond adalah triple kan. Mana ada fourth sampai apa quadruple bond. Okay, between the two atom between the two atom. I'm talking about the two atom. Okay, dia okay, please take note that sigma is stronger. Sigma are stronger than pi bond. Okay, sigma are stronger. Can you imagine you have an accident, ada accident, you imagine bila the two cars collide with one another, okay, end to end, maksudnya apa, bertentang, maksudnya pelanggaran bertentang dengan pelanggaran sisi. Which one is stronger? Which will have stronger impact? By right, yang berlanggar face to face lah, yang directly ni berlanggar depan dengan depan, dia punya impact is stronger compared to kalau you langgar sisi. Kan, damage is still there but it's not as bad compared to kalau you collide, okay, face to face ataupun end to end. So that is the analogy that we could use to imagine why pi bonds are stronger than sigma bond, because pi bond they overlap. The more region they overlap, lagi banyak the orbital overlap, that means the stronger the bond. Okay, we know that for sideway dia sikit je kan, they overlap kan. So the region they overlap represent the strength of the bond. Okay, alright. Okay, sigma and pi bond refers to carbon atom. So single bond, it will be first will be sigma lah. So single bond, kalau dia between the two atom form single bond, so that bond is called sigma bond. If we have double bond like I've shown to you just now, that means it will be one sigma bond and then the other one is pi bond. Macam ni, this one. Between C dengan N. Okay, triple bond, that means we have one sigma bond and the rest are all, the rest are pi bond, macam ni. Sigma and then pi. Okay, so between carbon and hydrogen, so we have single bond kan, it will be sigma. Okay, so single bond will be sigma lah. So if we have double bond, one is sigma, one is pi bond. Okay, triple bond, one is sigma, the other two will be pi bonds. Okay, alright. Orbital hybridization is hybridization. Hybrid means kita combine something and then producing something new, betul tak? That have these two characteristics of the parents just now yang kita combine tu. Imagine you hybridkan kucing. Okay, kucing ni ada bulu panjang. This one has cute face. When you combine, so we expect that the hybrid would have these two traits of the parents just now. Okay, so same goes to orbital hybridization. They can hybrid, boleh hybrid. Okay, so orbital hybridization is a concept of mixing atomic orbitals into new hybrid orbitals. Mix of the orbitals that have different energies and shape. Okay, of course bila dia combine, dia ada trait yang macam parents dia tu, and also dia ada new trait. Okay, in this case, orbital tu akan ada different in energies and shape. Okay, alright. Total number of atomic orbitals involved in hybridization is equals to the number of electron pair. Okay, nampak ni electron pair. So kita kena determine, okay? How do we determine the number of the type of hybridization form? Okay, is based on the number of electron pair, or like last time, I would prefer to use electron group. Okay, saya cakap kan, hybridization depends on electron geometry ataupun electron group. Depends on the electron group. For example, how do we know how many orbitals that need to be hybridized? Berapa banyak orbital yang kena hybridize? Okay, dia punya tips dia adalah to identify the electron groups in the central. Macam biasa, in the central ataupun on the central. So if we have 2 electron pairs or 2 electron groups, it will be S dengan P hybrid orbital. Okay, alright. So kita punya hybridization yang kita cover in our syllabus is between S dengan P. Okay, S dengan P, SP dengan D. Okay, SP and SP dengan D. Kita tak cover F. Okay, kita tak cover F because F is already, F ada banyak apa nama tu, orbitals kan, and it's complicated. Okay, so we do not cover for F. And then for S also, for D orbital pun kita cover not for double bond and triple bond. Okay, kita just cover very straightforwardly, maksudnya when they overlap, what is the shape of the apa nama tu, what is the shape of the geometry form, and then what is the how do we draw the orbitals. Okay, tak apa tu later okay. Alright, so basically SP ni is the type of hybrid orbital because we have S dengan P orbital kan. Initially we have S orbital, we have P orbital. So when these two combine, they can combine. So that is what we call hybrid. Okay, it will form SP hybrid orbital. So that is what SP hybrid orbital means. It is a combination between S dengan P. Okay, and if we have S ada satu, and then P kita ada 2 P kan. Remember we have PX, PY, PZ kan. Okay, so kena recap balik PX, PY, PZ tu. How do you draw the P orbitals? So it will form SP2. Okay, alright. Okay, steps guys, steps to determine the hybridization of the central atom. So first and foremost, you have to draw the Lewis structure, the correct. Okay, if I may add in, you kena draw the correct. Tapi understood lah, Lewis structure should be correct lah in order for you to proceed to the next step. Okay, draw the Lewis structure of the molecule. It should be correct. Okay, and then you nak go for hybridization. Tadi kita dah go for the geometry kan, for the polarity and whatnot. So now if let's say the question is, the questions asking for determine the type of hybridization for CH4. Okay, so how do you identify the type of hybridization for CH4? Dia punya step dia macam biasa, kena ada Lewis structure, and then you have to count the electron pair ataupun the electron, lagi sekali saya suka pakai group. Okay, the electron group can be in the form of bonding pair ataupun lone pair. Basically you total up these two. Okay, so you totalkan, that will be your electron groups. Okay, and then from there, as simple as that, you can next determine the hybridization state of the central atom. So ini kena hafal. Okay, you dah hafal 5 basics electron geometry kan last time, which is this one. You dah hafal kan? So you dah tahu dia ada kalau 2 group, it will be linear. Kalau 3 group, it will be trigonal planar, 4, 5 and 6 and tak ada so on. Sampai 6 saja, okay? Alright. So simple saja, hybridization pun ada 5. We only have 5 type of hybridization. If it's linear ataupun if it has 2 electron groups, it will be SP guys. 1 S orbital, 1 P orbital. So in total berapa? 2. Sama tak dengan electron group dia tu? Sama. Okay, if we have 3 electron group guys, if we have 3 electron group, 1 S orbital, 2 P orbital. 1 plus 2 will be 3, which is the same as electron group just now. If we have 4 electron group kan, dia kata sp3. So hybridization will be sp3. How do we get sp3? Kenapa sp3? The simplest way will be you count the number of the orbital. So S ada 1, P ada 3. 3 plus 1 will be 4. Kan sama dengan electron group dia, sp3. Kenapa S mesti 1 saja? Sebab S ada 1 saja. P kan ada 3. Kan maximum we have 3 p orbital. Px, py, pz kan. So that is why we have 3 p orbitals. Okay, it can be hybridized. If necessary lah. In this case dia 2 p saja yang perlu hybrid. This one kita ada 1 p saja. Okay, alright. 5. Kalau 5, sp3d. Sebab maximum p orbital we only have 3 saja. Okay, tapi dia still kena hybrid sebab tak cukup nanti. Macam mana elektron tu dia akan tak cukup for central. That means we have to have d orbital. So it will become sp3d. Tapi 1 tambah 3 tambah 1. So in total we have 5, which is the same as electron group. Okay, and last but not least will be sp3d2. So in total we have 6 juga guys. 1, 3 tambah 1 tambah 2, 6. Okay, so please guys, please remember this. So saya tak nak nampak tiba-tiba ada sp4, sp5. This is wrong. Okay, the reason dia sampai p3 because we have 3 orbitals only. We do not have more than that. So kenapa mengada letak sp4, sp5, sp6 and so on. P ada 3 je. Next will be D. So this is wrong. Okay. Somehow ada juga yang buat nanti. So ini je yang you kena memorize. SP, SP2, SP3 and then it depends on the electron group. So you have learned about this in earlier slides kan. So it's not something that difficult and then dia ada 5 saja and then you have the logic behind it. Kenapa dia SP? Because it's a combination between S and P. Okay, I hope that would help you to memorize better. Okay. Alright, so it's between SPD. We don't have F for our syllabus. I'm not talking about F tak ada hybridization ada, but we do not cover that in our syllabus. Okay? Alright, so this is how dia form how the orbitals looks like. Okay? When they combine, when these two combine S dengan P dia jadi SP. So dia ada 2 hybrid orbitals. So macam mana rupa dia? Macam ini. This is a combination of S dengan P. Dia jadi bentuk macam ni. Okay? Alright. So dia linear. SP2. Ada berapa? Sama je. Kenapa dia buat bulat-bulat lonjong macam ni? Sebab remember, hybridization is based on electron group, electron geometry. Kita tak fokus dah pada atom-atom dia tu. Atom tadi tu for molecular geometry guys. Okay, we don't have this already. So that's why rupa dia begini. So this is the shape. As you can see, shape dia sama dengan what we have learned in Vesper last time. You kena draw based on trigonal planar. Macam mana yang saya ajar tu? Begini. Just transform. Later you kena transform in this shape. Okay. Alright. And then we have sp3. That means you combine 3 and 1 s orbital. So this is how it looks like. Okay. The bond angle, the shape are basically the same as what we have just earlier. Okay. sp3d maksudnya dia combine sp-p-p-d. sp3d. So the shape is trigonal bipyramidal. Okay. Alright. And so on lah. Okay. State the type of hybridization of the central atom. Okay. For BeH2 and NH3 you kena ada Lewis structure. So these are the steps. Kena ada Lewis structure guys. Okay. And then you have to identify. Once you have the Lewis structure, because we want to determine the hybridization only. Kita tak nak tahu dia punya geometry ke apa, polarity tak nak. Okay. Kalau based on this question. We want to determine the hybridization. So what we need to do is to count the electron group on the central. Once we have counted the electron group, we can determine the type of hybridization based on the table that we have just now. Okay. This is the Lewis structure. And then how do we determine the type of hybridization? Kita kira the number of electron groups. So we have 1, 2. Okay, 2 electron group. That means it is sp guys. Okay. Alright. So from the Lewis structure tu, that means from the Lewis structure, katakanlah you belum draw lagi based on the electron geometry. It's not dia tak salah because we just want to determine the number of the type of hybridization. Okay, so from the Lewis structure pun kita boleh determine the type of hybridization without having to transform into the correct geometry. Katakanlah this is your Lewis structure kan. Nak determine the hybridization, just count the number of total electron group on center. 1, 2, 3, 4. Dah boleh dapat dah sp4. Okay, tak perlu transform into the correct geometry lah. Okay, because we are talking about type of hybridization. If you are talking about polarity and so on tu, you kena transform into this. Maksudnya it's simpler lah. It's simpler because ni just nak state saja. State maksudnya it will be 1 mark. Later kita akan belajar how to draw. Okay, tu cerita besar lagi. Okay. Right. Okay, why must they hybrid? Kenapa dia baru keluar sekarang Patutnya dia kena keluar awal-awal. Kenapa dia kena undergoes hybridization? Kenapa tak just overlap? So that will be the question. Okay, kenapa nak kena hybrid? S dengan P nak kena hybrid. Kenapa tak S dengan P overlap je lah macam hydrogen, HF just now kan? Why do they need to hybrid? Okay, the atomic orbitals must hybridize in order to form bond. Okay, because if it's not hybrid ataupun if it is unhybridized, kalau dia tak hybrid, the orbitals predict the inaccurate bonding and geometry. Okay, remember kita ada model then we create theory. Bukannya kita create theory, kita kena ada evidence dulu. Then from there kita create theory why is that so and so on. Kita punya question and tu Okay, bukan kita create theory lepas tu kita ada reality. Bukan, kita ada reality dulu. Then only from there kita study, kita create theory. Okay, alright. So same goes to this ni. The reason we have to the orbital need to be hybridized because if not, the geometry will be inaccurate. Dia takkan dapat explain kenapa geometry tu macam tu. Okay, so scientists have came out that in order to get the reality punya ataupun yang betul-betul punya structure, bonding, geometry and so on, okay, the only explanation is to go through the hybridization. Dia kena go through hybridization. Contohlah, cuba tengok. Okay, we have CH4 guys. Okay, we have CH4. We know that C requires 4 more electron. Therefore, that's why dia kena combine, dia kena share dengan 4 hydrogen. Betul tak? So, by right, carbon tu kena provide, okay, dia kena provide 4 unpacked electron. Kenapa kena provide 4 unpacked electron? Because so that dia boleh share dengan 4 hydrogen. Logically speaking, betul tak? Kata share. Kan, kalau nak share, mestilah kena provide 1 electron each. Okay, 1 electron each. Ni kenapa begini? Ni kena ada lagi 1 tambah sebab S dah penuh kan? Sorry. We are talking about hydrogen. Sorry, saya ingatkan carbon. Okay. So this is hydrogen. So hydrogen requires 1 more electron. Betul tak? So we have 4 hydrogen. That means we have 4 unpacked electron. So this hydrogen, okay, requires pertolongan, help from carbon. So by right, carbon kena provide. Imagine in the orbital of carbon. Okay, in order to share the electron, by right the carbon kena provide 4 unpacked electron. Kalau logically speaking. Hydrogen is now ready. Hydrogen ready sebab dia ada 1 je elektron. Okay, nanti dia akan overlap dengan carbon. Okay, carbon on the other hand, dia ada 2 saja unpacked elektron. Tapi yang nak masuk nanti ada 4 hydrogen. Ini dah fulfill. That's why kita belajar hybrid valence theory sebab kita nak tengok dari segi orbital tu macam mana. Okay, as you can see, this is already fulfilled. If you disturb this orbital, that means tanpa ada strategi yang betul, dia akan gone to waste lah. Okay, so initially this is how how carbon looks like. Dia ada 2 je unpaired electron, tapi ada 4 hydrogen nak masuk ni. So how do you explain this? Kalau based on this, you akan dapat 2 hydrogen saja yang masuk. Is this possible? Do we have CH2 without having double bond ataupun carbon? Kita ada C2H2. We do have this, but we don't have CH2. This is not possible. Kan? But we have CH4. Tapi how is this possible kalau dia tak form hybridization? This is not possible. Mana ada this molecule is not possible. This is what we predict if there is no hybridization takes place. Okay? Yang kita nampak adalah this one, CH4. So how do you explain this? Sedangkan dia hanya ada 2 unpaired electron. So how do you explain the 4 hydrogen ni masuk? Macam mana dia masuk sedangkan ada 2 unpaired electron from carbon? Okay? So the explanation is through hybridization. Macam mana hybrid? Kita akan tengok. Okay, example of carbon hybridization. So initially unhybridized kalau dia tak hybrid. Hybrid remember kalau sp3 dia akan combine S dengan P. Okay, sp3 S dengan 3P. So this is S, this is P. Okay, so this is how carbon looks like for if it's unhybridized. Kenapa we have carbon saja? Because you know most of the compound consists carbon. Okay, so carbon is the most common lah atom present in Earth. Okay, alright. So and then one more thing, carbon can form so many hybridization. Okay, it can form sp3, it can form sp2, it can also form sp. Okay, alright. So just to give you an idea how they combine, how they form, how hybridization takes place, bagi idea so that nanti you boleh imagine later. Kita akan tengok setiap satu sp, sp2, sp3, sp3d, sp3d2. Macam kita tengok Vesper last time. Okay, right, sp3. Okay, 1s combine dengan 3p. So initially this is how it looks like. Betul tak? Okay. Okay, perasan tak kenapa dia single? Sebenarnya one of the electron from s orbital will be promoted ataupun will jump into the 2p orbital. Okay, mind you this requires energy. Tapi berbaloi ke tak berbaloi? So in this case berbaloi lah sebab dia nak become more stable. Okay, alright. So this one sebab dia contoh CH4 just now kan, it will form sp3. Remember? CH4 will form sp3. But how this sp3 form? Okay, dia macam mana? So kalau unhybridized sebelum, this is how it looks like. Dia perlukan 4 unpaired electron. So to prepare that this electron will be transferred to the p orbital yang kosong ni, this orbital. So bila this transfer, they transfer to the p orbital, promoted into the p orbital, and not only that, they will combine. This is what we call hybrid. Okay, so dia akan jadi single kan. This one once dia dah transfer dia akan jadi single. Kan dia ada satu saja tinggal because this one has been transferred here. Okay, alright. So dia akan combine guys. They combine, so it will form sp3. Okay, ini first idea nak bagi kat awak. So dia akan, this is what we call sp3. Then later on hydrogen bolehlah masuk, bolehlah pair. So ada 4 hydrogen. Okay, because hydrogen ada satu s. Every hydrogen has one electron in the s orbital. So they can form. Okay, so central yang form hybridization, not the terminal atom. Central. Okay, alright. Then we have sp2, sp3. As you can see, nampak tak? They combine. So initially dia begini. Begini. Kalau dia dah hybrid, if yes sp3 dia jadi begini. Dia lompat dulu and then they combine. Okay, so that is the idea of it lah. Alright, so this is what yang saya cakap sp3. So kita kena stop dekat sini. So we will continue this macam biasa on Wednesday guys. After all, tomorrow is our public holiday. Okay, kita punya beloved prophet punya kelahiran. Okay, so banyakkan tiba-tiba banyakkan berselawat. Okay, so kita cuti esok, so our replacement class will be on Wednesday macam biasa. Okay, so this dan yang lain-lain SP3D sampai tu will be covered in our next lecture. Right? Okay, ada soalan ke? Lupa nak tanya. Syok je bercakap memang seronok. Any questions so far, guys? Okay ke? Faham ke? How you guys doing so far? Are you guys doing okay?
Okay, madam.
Okay, okay, hopefully saya go very slow, sangat-sangat slow untuk you guys. Make sure berbaloi lah, make sure worth it lah. Letihnya, sedihnya saya bila still tak faham. Okay, saya akan upload all the videos dekat saya punya YouTube channel. Okay, so please tengok, fahamkan. Okay, alright, if there's no question, I think that's all for today, guys. Thank you everyone for your attention and Assalamualaikum. Bye-bye.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Okay.